begin with the double angle formula for sine. The double angle formula for sine comes from utilizing the addition formula for sine that we saw in the last lesson. So we know that sine of x plus y is equal to sine of x times cos of y plus cos of x times sine of y. So what happens if we take this addition formula and we replace y with the variable x? Well, if we do that, we should get sine of x times cosine of x plus cosine of x times sine of x. And notice that these two terms are actually the same over on the right-hand side, so we could simplify this to 2 times sine of x cosine of x. Now, our last observation is that x plus x is equal to 2x. This is why we often call it the double angle formula. So here's our double angle formula for sine. Sine of 2 times x is equal to 2 times sine x times cosine of x. Next up, let's try to find the double angle formula for cosine. Recall that the addition formula for cosine looks like the following. Cosine of x plus y is equal to cosine of x, cosine of y, minus sine of x, sine of y. And what we're going to do is we're going to take our y and we're going to replace that with an x to get cosine of x times cosine of x minus sine of x times sine of x. Well, this is the same thing as cosine squared of x minus sine squared of x. Now this leads us to a couple different simplifications we can have for the double angle formula for cosine. Since we have the identity sine squared plus cosine squared is equal to 1, if I move the sine squared term over to the right-hand side, then I get cosine squared equals 1 minus sine squared. And if I were to move the cosine squared term over to the right-hand side, I could get sine squared is equal to 1 minus cosine squared. So I have two possible substitutions I could do for cosine squared or sine squared. So first, we could say cosine squared is equal to 1 minus sine squared of x. And if we simplify this, we're going to get 1 minus 2 times sine squared of x. Alternatively, we could take this sine squared x and replace it with 1 minus cosine squared of x. And when we simplify this, we're going to get 2 times cosine squared of x minus 1. So this leads us to two different but equally acceptable representations for cosine of 2x. Either we can write it as 1 minus 2 times sine squared of x, or we can write it as 2 times cosine squared of x minus 1. Now it may not be immediately obvious which one is the favorite, which one we should choose. Usually you have to figure out which one to choose based on the context of the question. In this example, we'd like to determine the value of sine 2x if we know the following information. We know that cosine of x is equal to 2 over 3, and we know our angle x is in quadrant 1. Since x is in quadrant 1, we can draw a right-angled triangle like this, and we know that the ratio of our cosine function is 2 over 3. That means that the adjacent over the hypotenuse is 2 over 3. So if we want to figure out sine of x, or tan of x for example, we need to figure out this other missing side, which we can do using Pythagoras' theorem. So our missing side, let's call it a. A is equal to 3 squared minus 2 squared underneath the square root sign. Or that's going to be 9 minus 4 for the square root of 5. Now that we know all three sides of this right-angled triangle, we could determine any of our trig ratios that we need for the question. In particular, we want to evaluate sine of 2x, which we know is equal to 2 times sine of x times cosine of x. We already know that cosine of x, that was given in the question, is 2 over 3. So we can fill that value in. And from our diagram over here, we can now solve for sine of x. So sine of x is opposite over hypotenuse, or square root of 5 over 3. And multiplying all of these values together, we're going to get 4 times the square root of 5 over 9. In this last example, we're going to take cosine of 3x and try to rewrite it in terms of only cosine of x. So in this case, we have a triple angle. And what we can do in these cases is we can break this down into the cosine of 2x plus a third x, like this. And then we can apply the addition formula, where one of our terms is 2x and the other one is x. Applying the addition formula for cosine, we're going to get cosine of 2x times cosine of x minus sine of 2x times sine of x. Now, from here, we do know the double angle formulas for cosine and sine, so let's substitute those in next. Since we want our final expression to be in terms of only cosine of x, it makes sense for us in this instance to replace cosine of 2x with 2 cosine squared x minus 1. Remember that I can replace cosine of 2x with 1 minus 2 sine squared x as well, but like I said earlier, it depends on the context. In this context, we're looking to get our final answer in terms of only cosine of x, so this makes more sense for us in this particular case. Now next, we'd like to make a substitution for sine of 2x. And sine of 2x is 2 times sine x times cosine of x. So actually I'm going to start a new line here, so let's go minus 2 times sine of x times cosine of x times sine x. Now our next step is going to be to distribute through our brackets. So cosine, I'm going to distribute that through the brackets up here, and that's going to give us 2 cosine cubed x minus cosine of x. And if we drop our brackets here, we can do that because there's no addition or subtraction on the inside. We're going to get minus 2 times sine squared x times cosine of x. Now, the only thing we have left to do to get everything in terms of cosine is to try to remove this sine squared x. And to do that, we can use the Pythagorean identity. So we'll go ahead and replace that sine squared with 1 minus cosine squared. And then what you want to do is distribute 2 times cosine through the brackets. So here's our first step that we get after we distribute the cosine through. We're going to get cosine of x minus cosine cubed of x. And then our next step here is to distribute that 2 through. So I'm going to erase everything that I have and start fresh up at the top. And after we've distributed the 2 through our brackets, our last step here is to try to collect like terms. So we have 2 cosine cubes here. We're going to add 2 more cosine cubes to that. So altogether we have 4 cosine cubed x's. Here we have a negative cosine of x, and here we have 2 more negative cosine x's. So altogether we have minus 3 cosine of x's. So our final answer here is 4 cosine cubed minus 3 times cosine. Alright, my little epsilons, stay positive.